Good morning, good afternoon, good evening, and welcome to another IWA's Intermittent Water Supply Specialist Group seminar. My name is Razia Farmani. I'm the chair of Intermittent Water Supply Specialist Group. It's my great pleasure to welcome our speaker today. Hassane Ben Ahmed is a seasonal engineer with over 30 years of experience in variety of roles within the water and sewage industry, Morocco, Algeria, Tunisia, Benin, Sierra Leone, Ethiopia, Zambia, Saudi Arabia, Qatar, and India. His early career was a site supervision engineer of construction works of waterworks and concrete reservoirs. Then he moved to operations and maintenance of water networks, including leak detection and non-revenue water reductions in Casablanca, Morocco. Since 2010, he is working on international projects involved in non-revenue water reduction and construction of new water networks and operation and maintenance of water networks. He has considerable expertise in water distribution management and its optimization, particularly with respect to non-revenue water reduction, pressure management, GIS, bulk and customer metering, customer billing, and finding illegal connections, leakage detections. Currently, he is working in Saudi Arabia as general manager of Makkah City Business Unit. It's my great pleasure to welcome Hassane. Just for all our participants, there will be a Q&A at the end. Please feel free to turn your microphone on and ask your questions or type your questions in the chat for Hassane. Thank you.
Okay, thank you. Thanks, Razia. Good morning, good afternoon, and let's say maybe even good evening from Mecca, from the sunny Mecca, which is now, it is 32 degrees. Anyways, my talk today is the intermittent supply. Actually, is it fatality? And I think I will start with some figures which are coming from UNICEF regarding the water scarcity. I mean, we can see that there are 4 billion people that experience severe water scarcity for at least 1 month each year. Over 2 billion that they are living in countries where water supply is inadequate, which means that's not drinkable water supply or maybe intermittent water supply. Half of the world population could be living facing scarcity by as early as 2025. And we can see that in so many countries that were last year or the years before, that there was less rain, so there was less water. And I can make reference to my, let's say, to my own country, which is Morocco, for the last few years, that there was no rain. And of course, water is becoming very scarce, and even in some cities, they started having intermittent supply. And anyways, that's another project that's maybe someday we'll be talking about this. Yes, of course, yeah, for the water scarcity, of course, all of us, we are just human beings and we are looking for adequate water. So we can imagine that there can be some 700 million people that could be displaced that's looking for water. And by 2040, roughly 1 in 4 children worldwide will be living in areas of extremely high water stress areas. So we hope that we are not going to reach to these points, and we have all of us to work towards this path. So my talk will be about India. In India, actually, I worked in India back from 2013 to 2015. For 2 years, and I was working in Delhi. So the discussion today will be regarding India on the project. That's where we worked. Of course, yes, all of us, we know that it is a large country, and it is the first most populated country, and I think it is around 1.4 billion as of 2023, and we can imagine now it is maybe 1.5. The gross domestic products, we can see that it is increasing And especially like since 2007, we can see the jump in 2021, and it will continue jumping. So it is a country, and it is, of course, the largest the democracy in the world. Delhi, as a city, it is a huge city. And we can see from, let's say, from this graph that in 96, it was 2.28 million. When I was there, like back in 2015, it was already 25 million and something. And now, I mean, we look at the projections, it's absolutely very big numbers. I mean, actually, when we are talking about Delhi, it is the NCR, which is the National Capital Resident Area. According to an economic survey that was done in 23-24, Delhi has daily water demand of 4.8 million cubic meters. Out of which, DGB, which is the sole supplier of water supply in Delhi, which is Delhi Jal Board, is currently producing around 3.8 million only. So there is missing 1 million cubic meters daily, which is missing in the entire city. And this water, of course, it is coming, let's say, from the rivers, which is not, or maybe from boreholes. So the water scenario in India is quite, you see, it is quite alarming. I mean, back in 1951, I mean, the water availability was 5,200, but in 2021, 1.5, let's say 1,500 cubic meters. I mean, this decrease, it is quite a lot, which is just, let's say, just in 70 years, which is a lot. And we see, like, for example, in India, where we have the monsoons and everything, but still, we still have this problem. And it is estimated it will be reducing much more by 2050, if it is not before. The work in India, and as I work in India, I mean, what we can see, like, is that there is inadequate sizes of pipelines. I mean, actually, because of the cities they are developing, and the cities and the water demand, of course, it is changing at the same time. And there are areas where they used to be, let's say, residential, and after they were changed, or they were improving, like having high-rise building without at the same time changing the diameters of the pipes. So we are keeping the same pipes for more people, but with the same pipes. Average non-revenue water, which is quite very high, it is across India, it is between 50-55%, and it might be alarming in some other places. The concept of water supply, anyways, back at that time when I was there, it was not a prevalence concept in India. And even I think there are some critics on the new document that was produced by CPHEEO, that was produced by GIZ last year. And still, I say that there is no change with the one which was produced back in 1999. So maybe there will be some let's say, measures or some things that will be missing. Of course, continuous water supply is required for reducing, of course, non-revenue water, because this is what we are looking at. But at the same time, it addresses also health issues. Because usually when we have non-revenue water, we have intermittent supply with many leaks on the pipes. And if there is sewer next to it, there will be intrusions from outside. So these intrusions from outside will be giving polluted water in the pipes that we will be distributing, and after that, of course, we'll have health problems. The project's objective, the projects I was working on in Delhi, it's to ensure equitable and 24/7 water supply in the project's area. I mean, why we are saying equitable? Because we used to have 2 areas. I mean, actually, there were 4 areas. I mean, in this, there were no, actually, there were 5 areas. In 4 areas, the supply was intermittent, of course, in the morning and in the evening, for 1.5 hours in the morning and in the evening. But for the other area that they were receiving water like every 3 or 4 days. Of course, yeah, the next objective is rehabilitation of the network of distribution system. and supplying water for this series. There was this Mehroli and Vasant Vihar. It is actually Vasant Vihar and adjoining adjacent neighborhoods. Improving the water system, revamping service connections, because they were also customers without even without connections. I mean, that's with irregular connections. And of course, rehabilitation and of the pumping stations. And of course, yes, the road restoration and establishing 24/7 consumer complaint center. The intermittent supply, that's what I was saying, like, for example, we have this parts of the say 48 hours to for a few hours. Large number of valves operations. This is the situation that we found at that time. And there was one area in, it was around 3 kilometers of pipes where we used to have 65 valves, for which we just don't know where they were, all of them. The distribution, yes, as we said earlier, it was inadequate size of pipelines. The distribution system and even the pumping station, they were absolutely very old. The network, yes, of course, without detailed engineering, and the large number of leakages. And we were distributing waters as well by tankers. And of course, there was, in this kind of situation, we cannot have even, of course, a large lack of pressure management system. That's again, I would say that for every water utility, usually if we don't have drawings, we have GIS. In the parts where we're working in the city, there was no GIS, and even the drawings that we received, they were not updated for the same areas. Sometimes we used to have 3 to 4 drawings depending on the person who has these drawings. And of course, there is no update drawings. We used to have AutoCAD. I mean, several formats of the drawings that we received, but they were not accurate. And even sometimes we were receiving complaints from the customer because they were not either receiving water, or maybe they have bad water quality, so we couldn't just sometimes just don't understand why, for example, just this only customer who doesn't have water, and the neighbors, they don't have, they have water. So we had to go through several processes. We have to do excavations in order to understand what's happening. Most of the customers' meters were very old. They were mechanical for the ones who were installed. And of course, we know that with the aging for the mechanical water meters, how it impacts the accuracy of these water meters. And even the customers were not paying their bills. And even they said that it was intermittent water supply. With these areas, they didn't know at what time they will be receiving water. Is it at 5 in the morning, or maybe 5:30 or 6 in the morning? So at least if we know if it is at 5 in the morning, so like that, they can start, let's say, having their pumps working. But actually, we used to have customers that they were having automatic pumps. That's these pumps with sensors. When they receive water, when there is water in the network, in the connection, the pumps will start automatically. The customers' pumps were installed directly on the connections, which is, it was in India, it is illegal. It is not legal at all, and which is all over the world, it is not legal. But still, the customers, they were installing their pumps directly on the connection, because these pumps installed on the connection, they are creating leaks, they are creating water hammers on the network, and they are even the joints that they will be disappearing during the time. Of course, the customers, they were not satisfied. I mean, if we don't know at what time we'll be receiving water in the morning or in the evening, the exact time, so we just don't know. We had, of course, large number of unregistered connections. I mean, this is one of the problems with intermittent water supply, because with the intermittent water supply, there is no pressure on the network, on the pipes. And the having connection done on the pipe during that time is absolutely fantastic. It can be done without any issues. There was also the pumps. They were not working at their optimal because they were very old. And I think their optimum points will be kind of 40–50%. And of course, poor maintenance of the existing network. So in order to transform from intermittent to 24/7, we cannot just say, okay, we will start doing it, and we start doing it by tomorrow. Before that, we had to discuss with the customers, and we have to discuss with the customer representatives. And here, for example, in India, it was in Delhi, which was absolutely fantastic, that they have what they call the RWA. RWA, which is Resident Welfare Association, and it is representing the customers or the residents in what they call colony. I mean, for the colony, they used to have their own tank, so they were not connected to the other colonies. So water is coming to their tank, to the tank for the colony, and after that distributing from there. And Delhi, by the way, it is flat city. So which means like that we are pumping all the time whenever we are distributing water. What we did, so we went through discussions with the customers. The idea was with the customers, like to tell them, okay, that we are going to transform to 24/7, but we cannot do it if they keep their pumps connected to the connections. So we were asking them to disconnect their water pumps, but we engaged with them, of course, through the entire process. They were involved, I wouldn't say since the design, but basically kind of since the design until the installation. And we were having like every weekly meetings with them, and in order to explain what we want to do, so like that they understand, so like that they can remove their water pumps. And actually that's what they did. We said, okay, you can put them aside, you can keep them, that's if in the future we have the problem, you still have your pumps. So in the first area, as pilot area, so we changed 2.5 kilometers of new pipes, and we decommissioned the old network. All the customers, they were equipped with the new smart meters. We removed all the connections, new smart meter. And of course, new pumps were installed. And these pumps were demand-driven in order to meet the peak and the average. And actually, we used to have the pressure points at the pressure sensor at the critical point, which was communicating to our system in the pumping station. That's when there is less pressure, let's say it was less than 1 bar, it can start. So there will be, and I will show you the picture. I mean, this is the picture that we have for these pumps. We used to have, let's say, for this area, these 3 pumps and large ones, and all of them, they were VFDs. And we have the small ones. So it was depending on the demand. If we will have 1 pump, because of course we have all of these scenarios regarding the starting of the pumps and how many pumps will be starting at the same time. And of course, in order to keep during the night, one of the small pumps working, so like that we keep pressure on the network. So like let's say that someone will wake up in the night and they want to go for shower, let's say for the toilet, at least when they will open the valve, of course the other pump can start at the same time. So that's what we did. So from this, what we realized, I mean, that it was possible that to increase water supply from 2 hours or maybe less than 2 hours per day to 24 hours per day because of the genuine working of the pumps. The complaints of tankers that they were all the time, that they were complaining the customer because they were not receiving enough water, so that completely they were non-compliant when we started working this way. All the boreholes, because we used to have also boreholes in the area, that they were phased out. And non-revenue water, it was reduced from 60% to around, and even less to 10%. It was actually in that first year, it was 6.7%. And most of the losses that we had at that time, they were on the fittings. I'm talking about 2014. And what we did at the same time, because we know for all the networks that we have some customers that they are using more water than other customers. So of course, from our customers, 92 customers, which is around 24%, that they were using 38% of the area water total demand. And I remember and it was a residential area, and there was one customer, their consumption, it was absolutely, I would say, very huge. I mean, and at some points we were thinking if we can install kind of diaphragm, so like that we can reduce at the water meters, that we can reduce their water demand, that to have it split during the day and not only in few hours, because this customer, they were disturbing the system. So this is what we have. And at the same time, like what the thing that has happened, because with this pump that they are working when the water demand is there, because they were, of course, new pumps, and their design helped us, like the energy as well, that has reduced by 95%, the energy consumption at our own pumps. Can you imagine for the customer that they were using their pumps from the power? So how much they have gained, or they say the profits kind of that they have done because they have reduced the energy consumption. And even the demand, I mean, actually you can see it's on the rise. I mean, we used to have 0.67 million liters per day. So it has increased to 0.72 million liters per day. I mean, it was not that much. I mean, it was not, we were not too much increase. And this is for the hours of supply, and this is for the pump house where the pressure that we have, we can see on the left. And on the right, we have the critical point, which was the gauge for us to know exactly if we are distributing, the water is distributed 24 hours or no. So this is, that was done on 25th of January. And we can see, like, and even during the night, that's, yes, of course, was not, because during the night that the water demand was absolutely very low. So what happened next? What happened next? It was absolutely very simple. I mean, from my left, I left from there back in March 2015. But actually, the company, I mean, the contract for that project, it finished also this year, 2024. And what they did, okay, as long as it was successful in that area, so they said, okay, we will do it in 2 other areas. So that's what they did. You can see the pumps on the right and the pumps on the left. So you see, it is just a similar setup that they have done, and they did the same. So, for example, for this one, for these areas, again, they shifted to 24/7. And of course, for these 2 areas, there was a reduction of non-drinking water from around 60%, if not more, to 15%. I mean, this is what happened, I think, back in 2019 or maybe 2020, because there was, from the return of the experience from the company and from what happened, they were encouraged, like, to go on. And of course, yeah, the company, they wanted to extend the contracts, and which is not possible for reasons that honestly just I don't know. But anyways, that they were not extended. So energy efficiency at the pumping station, all the customers, they were connected to the pipe network, because with this, we are sure that there were no illegal connections, not single one. And of course, yeah, the customers also, that the engagements where we went through them with the discussions, is that they will have to pay their bills, because we are surviving from the bills. If they don't pay the bills, we will go back to the old system. We had the 24/7 also, the customer call center that they can call at any time if there is any problem. And we have our team that they were working 24/7, and even my successor, they continued in the same way. Of course, yes, the collections has improved a lot. And the tankers, they were absolutely banned from entering this area. So like that, we are sure that we are doing the things right. I mean, this is, yes, that's professional review where they are talking about the project that we did in India. And with the progress that's happened, this one was March, April 2022, this article that was done, but it is still, things are still good. And I'm happy that I worked on those projects, and that we could do something right, and that we can show that we can supply 24/7, and this is my conclusions, and we can do this supply. But what will be the cost? Because when we look at the areas where we're working, of course, we did the rehabilitation of the entire network. Yes, it is costly. That's something that we cannot, for example, do for entire Delhi, where we have more than 15,000 kilometers of pipes. So it is a lot of money. So that's the cost that we have to look at it at the same time. Maybe with the same network that we can do some hydraulic modeling, or maybe like to reduce the water demand. Because, for example, for these areas where we were working, the water demand, and can you imagine, that was around 250 liters per capita per day. 250 liter per capita per day. So if it can be reduced, and for example, from my experience from Casablanca, where I was working, it was less than 80 liter per capita per day. So it is something that we have to think of, because, and of course, yes, people were distributing water 24/7, and everything was clean, and everyone was clean, so there was nothing dirty. And of course, we need a correct design of the infrastructure, that we have to know if we are using pumps, what kind of pumps that we are using, what kind of efficiency that we want from these pumps. It's that we cannot just having the pumps that we like, but it is something that we have to go through this calibrated hydraulic model, so like that we can know exactly what kind of pumps that we need and what kind of network that we will have. Because I mean, when we look at the NRW process, I mean, NRW starts from procurement of the material that will be used in the construction, in the laying pipes, in the house connections. So this is, let's say, this is what we have for non-review. If we have good material from the beginning, of course, we will have less leaks, less problems when the network will be starting working. So again, when we are looking for very good materials, again, the price is quite high. And we need as well that all the customers, they need to have water meters. Of course, we know the problems with mechanical meters and their aging process and their loss of accuracy during their aging. And what we need smart, let's say, smart meters. Smart meters, of course, they are installed. And of course, what will happen is that's how we will be doing, of course, this reading, that we'll do the follow-up 24/7 at any time that we can have the idea. So we have there is again another cost for the batteries and for the smart meters. If they are usually the batteries, they are 10 years, they're 10 years life. So if it is 10 years, we have to think about changing the batteries like every 10 years, or even if it is 15 years. So it is not lifelong lifespan batteries. So it is something that we have to change them. And if we have problems, that we have need team to be ready to be on the site all the time. And of course, yes, the cost of maintenance of these meters and the gateways for the meter readings and different scale, because for the reading mechanical meter, that's what we need. We have just books, or maybe we have in tablets, and after that we will be writing the figures. But with the smart meters, it is completely different. So we need, again, software in order to do the analysis of consumption and all the different analysis. And yes, we need as well, I mean, our system, they should be built in need-based usage of water. Because if we are giving too much water, we'll be giving too much pressure, and too much pressure will lead to too much leaks. So we need to give the enough water when it is needed. Of course, we have to keep the pressure at the level that we cannot accept any intrusion from outside. And for example, India, yes, it was that we decided it was more than 1 bar. So we are sure that if it is more than 1 bar, that there will be no intrusion from outside. And in other countries, there is 2 bars, which is quite high. But even during the night now, they started with pressure management, reducing it to 1 bar, 1.2, something like that. So again, we need specific equipments and of course, specific manpower. And of course, our customers, they are the ones who are paying the bills. They are the ones at the end of the day, they are paying our salaries, I would say. So they have to be involved in the change. We have to discuss with them. We have to educate them, to explain why we are doing this. It is in their interest. That's for sure. So like that, they can have water all the time. Whenever they open the tap, they can have enough water with very good quality. But again, I would say if it can be, will it be always possible? Because it depends, for example, in countries where we have the water that's coming from the dams or surface water will not be enough to supply water to the cities. So they will be needing desalination plants. We know that these desalination plants, they are costly. They are very costly. So we will have to increase the tariff for this in order to finance the investments the operational maintenance and finance, of course, the future investments, because we have to think, of course, of the future. So it is a balance, which is not easy. That's difficult to have, but it is something which is doable. It's not something that we cannot do. And I think, yes, it was my last slide. And I think we can open for for discussion and questions.
Great. Thank you very much, Hassane. Very interesting project and very informative talk. Thank you. So there are already some questions in the chat, so I'll start with those. But if someone wants to turn their microphone on and basically raise their question, feel free to do that. So we'll start with the ones in the chat. So the first one is why they have pumps? They have tanks in their homes?
Actually, and I can talk about where I was living myself because I know it very well. So they didn't have the underground tanks. It was pumping directly to the roof tank. So, and water was going to the roof, and from the roof it was going down.
So the pumping was mainly for pumping from underground storage to the roof. Is that
actually,
correct?
for example, usually what we have, it is that the underground tank, that's the water is coming to the underground tank, and from the underground tank, that it is pumping to the roof tank. But in our case, that they were having the pump directly on the house connection itself, so they didn't have the underground tanks. So they were pumping from the connection directly to the roof tank.
I see. Yeah.
So that's why that's, yeah.
Thank you. Next question is average water demand liter per capita per day under continuous system, and what is the cost of conversion project per connection or per person?
Honestly, I don't remember the cost of conversion for the projects, but it wasn't. I wouldn't say that it was very high. But honestly, I don't remember. But I can still check. Maybe can. There's my email that we can exchange on this. I mean, the average LPCD under continuous water supply, it was 250 liter per second, liter per capita per day. So 250.
Thank you.
Yeah. Before that, before that, it was just round because we didn't increase much the water supply. The volume, as volume, we didn't increase the volume that was reaching our reservoirs.
So basically, it was covered with the reduction in the non-revenue water, the amount
it was covered by non-revenue water reduction. That's for sure, because when you look, that we reduced non-revenue water from 60% to 6%, and no illegal connections.
Yeah,
which was absolutely very important.
Yeah, great. Next question is, what is the total population covered? Whether the entire network was renewed or replaced, it is because in the presentation, I could see that the non-revenue was reduced to 15% from 60%.
Yes, actually all the network was renewed, all the network. Yes, I can see that, yes, 15% seems still high, but I think what happens, maybe it was some workmanship that was not done properly regarding the jointing and the house connections. But at least for the areas where I work, that I know very well. At the time, most of the leaks, they were just on the fittings of the connection. The first question, the total population, it was not very. I remember that for the first area, and it was, I think, in the 3 areas, I think it was around 200,000 connections, be 2,000 to 2,500. I mean, the entire, yes, that's what I think it was, because they were still missing 2 other areas, which are the very large ones. But actually for this one, I think 2,000 to 2,500. I mean, Actually, it was in the beginning, we started with pilot area because we cannot go through this system in very large system. If we will go to in large system, we will be just lost. We start with the first area, so like this, we can see the benefits that the population they can get from water supply, from non-revenue water reduction, so that they can see the benefits. And after that, this path will be helping us in kind of advocating the water supply 24/7. So like that, we can in a way sell the solution to the other colonies, to the other areas, because usually, and this is, we are just a human beings, we say, okay, I'm satisfied with the current solution. So why are you bringing a new solution for me? I'm fine with this. I don't know what is the problem. But when you explain things like, for example, the kind of discussion that we usually have with our customers to say, okay, that you will have water, that you can at any time open the tap, you will have fresh water. And at the same time, your pump is not working. The energy cost that you used to have for pumping the water, it is not there anymore. So it will help you in paying your water bills. So it is kind of trade-off with the customers, so they will understand. And all of us, we are not far from our pockets. So we know how much we are spending and how much we are gaining. So that's why it is kind of, yes, this is how it is. Yeah.
Great, thank you. Next question is, have consumers stopped using household storage tanks?
They stopped.
Post 24/7. They stopped.
Yeah, that's what I mean. It was one of, we told them that they cannot. We say, of course, we are responsible of the water quality up to the water meter, and this is the responsibility of all the water utilities. It is all over the world. So, but we say, okay, if we want to have water, we are engaging, because the customers and you have, I mean, when you work with these RWAs, they are very tough guys. I can tell you that they are very tough. I mean, they know what they want, they know how they get it, and they want things done properly. I honestly, I was really impressed. I was really impressed with that mechanism that was working there. I mean, they were these residents' welfare associations. So they were saying, like, we were explaining to them, this is what we will be doing, and this is what we are doing, and this is how we are doing it. And they still remember there was one of the RWAs, it was absolutely very large area. And they said, okay, what we need the water level of the reservoirs at 8 in the morning that you have to share with us. So I told them, okay, it is not in my contract that this is information that I cannot share with you, but it is an information if you want to go through the process of the administration. So like that, we can through the process from the chief minister. So if we receive the order from him, so at that time that we can share, otherwise we cannot share. I mean, they were going in details and they were engineers amongst them. So like that's, it's not like to say, okay, that I will be saying kind of bullshit or whatever so that they will believe me. No, they were discussing really very technical, really very, very technical guys. So that's why like they say, okay, you want to do it like this, we rely on you, but we will see at the same time. And absolutely, they stopped using their underground tanks for the ones who have them, and they stopped using their roof tanks.
Very good, thank you. The next question is, in the case of customers failing to pay their bills, would they be disconnected from the supply?
Yes, of course, that's what's happening all over the world. I mean, like, there is the process. I mean, we cannot just disconnect the customer because of, let's say, of the first bill. And we will say, I mean, for the bill, the first bill, and maybe there should be a kind of what is the amount of the bills as well. And for the large customers, maybe, and of course, in several cities in the world, that they will say, okay, what we will do, the bill is high, that's what we can do. We can split it, you can have it, that you pay it, they say, in 3 months, 6 months, or even longer times. But it is something that it is discussion. And of course, if they are not, we will disconnect them. And after that, they will have to go to the tankers that we are managing ourselves. So like that, we can say, okay, these tankers that we are managing ourselves, go pay your bill, and the water will be cheaper than the water they will be getting from the water tanker.
Yeah, great. Any other questions from participants? Please feel free to turn your microphone on and raise your questions if you want. If not, I have a question. So you mentioned that energy usage has reduced substantially. So what are the key factors influencing that? Because it seems now everybody's receiving water, supply hasn't increased. So what were the key, you installed some new ones, probably
New ones,
more
yes.
more efficient ones, but the reduction is substantial. How did you manage to achieve that?
Yeah, I mean, actually, I didn't show the pictures of the old pumps. I did this on purpose, honestly, because they were absolutely very old. I mean, the pumps, when they were working, like I would say that the population next to it, they will just wake up with the noise that they were making, with the energy consumption that they were making, and with the cost of maintenance as well for these pumps. They were absolutely very old. I mean, with these pumps that we have here, I mean, it is standard pumps. I mean, they are very, with energy efficiency at the same time. So it's variable speed pumps that they will not be working at full speed when they start. They will be working for this was, they were like 3 speeds for the big ones. For the small ones, they were just 1. So and so like that's when there is this water demand at that time. For such water demand, the pump will start just at the first speed, and after the second and the third speeds. We're not at the same speed all the time. So the energy consumption was absolutely very low. And during the night, it was one of the pumps, which I think the pump which is on the left on the presentation, the small one that was working during the night. So the other pumps, they were not working at all.
So how about the price? Is energy fixed price or does it change by time?
I think at that time it was changing during the nights, especially because during the nights where there is the peak hours, and that's what's happening in several places in the world. Like with the peak hours, of course, there is energy consumption, which is, I mean, the energy cost is much higher. Yeah.
Okay.
More
There is another question here. Can you please share the cost recovery prior and post conversion? The entire network is new, which comes with high capital expenditure. What was the strategy adapted to recover those costs? By only means of tariff increase?
Actually, the tariff, we didn't, there was no possibility for increasing the tariff. But what's happened, I mean, for the, I would say we'll go back to the question again. I mean, because the tariff, we didn't increase. When you look at the cost of maintenance, because when we're looking at the investments, it's very easy to do the investment, but what is the cost of maintenance? And I've been working in countries where they have desalination plants. That's when you go there, the plants, it has less than 5 years. And it is absolutely in very bad shape because there was no maintenance. So the maintenance costs, they were costing us, I mean, the workers with the contractors who were working for us. Sometimes we say, okay, yeah, the workers, they are cheap. And that's not but again, when you're receiving complaints all the time, when you have to deal with you cannot predict what will happen in your network, which is absolutely very old. And I can tell you, for example, that there were customers, when the customer, they will start complaining that they are not receiving enough water. When you look at the maps that we have, it doesn't give you any clue. It's to see that there is continuous pipe. But actually what was happening that in some areas that we were checking, for example, in customers complaining if they are not receiving water, that we're checking the neighbors, the one on the left and on the right, and the one which is in front of the customer. So like that, we can check 4 to 6 customers to see exactly what is happening. So like that, to understand from where the problem is coming. So what was happening in several cases, that the customers, they were cut from both sides and they were having end caps. So the neighbors, they're receiving water and this customer was not receiving water. And we didn't know from where the pipes were going. So even if we want, yes, if there is a leak, maybe the leak it is 100 meters far from the point where it is happening. So that we see the leak that the water is going out 100 meters. So we will have to excavate and to excavate. So we will have to bring, yes, of course, excavators. And you have to do all of this in order to repair one leak or maybe two leaks or something like that. So again, I mean, it is these operation maintenance costs, these OPEX costs, which sometimes we say, okay, what is the cost? We will do it will be easy. But if I have a small problem of one of each pump on one of them, so the problem will be bigger and bigger and bigger if I don't repair it. And if I keep the same pumps for, let's say, 20 years or maybe 30 years, I will have to adapt new pumps. And that's what's happening. I mean, the pumps that I have seen, I think they have 40 or maybe 50 years old, and they were not working very well. So these costs, yes, we wanted to show at the same time, and for the contractors, of course, and for the water utilities, of course, they are not doing things for free. Of course, they are looking to extend the works, to extend their contracts, and to extend to have bigger areas. Actually, I think one of parts of the question, I mean, in Delhi, there were 3 types of the contracts. I mean, they have 3 separate contracts, not for the entire Delhi. There were 3 companies. The company I was the CEO, and 2 other companies, 2 French companies. So what they did, they wanted to see different scenarios. For our contracts, we were our payments, which is through the bills, that's were through our invoices, which was regarding the pubs that they were in, the designs and the studies, the hydraulic model that we developed. That's from where we were getting our money, from where getting our funds. There was the other contract was kind of a different contract that was from the different kind of concession contracts. And the other contracts, it was again build and operate and so on. So they wanted to see 3 models to see how they will be doing. For us, it was coming from the invoices that we were invoicing. Of course, there was the management fees, and of course, it was the fees. Let's say the fees according to the works that we were doing. So, and of course, to the billing and the percentage of the customers' bills that's we were receiving. So that was the capital expenditures was coming from there.
So to some degree, you covered the next question as well, which is saying, who funded the project and how did you persuade them that this costly long-term project was required?
I mean, because yes, for us, I mean, it was a decision because you can imagine, I mean, like working in water utility, and when you have problem, I don't know how to solve it because you don't have proper, let's say, maps. And for example, there was this one of these areas, I said like 3 kilometers of pipes in that area, 65 valves. And we couldn't see the 65. It was a figure that was given to us by all the employees. And these 65 valves, we couldn't see them on the, let's say, on the maps that we have. And even we don't know which valves, they were open or closed. And of course, when we are opening and closing the valves, of course, these valves, they are getting deteriorated by the time. They will be eroded from internally, and after that, you can open or close, will just the same. So you have to renew all this renewal program that we had to avoid. So it was not an easy decision, to be honest. It was not an easy one, but we had to take it. We said, okay, that we will have to go through. And of course, at the time, we said, okay, if we do it like this, we will be saving on our energy costs. We will be saving also on our expenditure costs.
I think the question is, who funded it? So initially, who paid for the capital investment for this?
I mean, it was our company. I mean, because when we were invoicing, we were receiving the payments. So our funds were coming from there.
Okay. The next question was what was the average percentage of recovery after replacing water meters, and how many of them were replaced?
The percentage of what was the average recovery after replacing? Actually, yes. For the water meters, actually it was less than 5 years, and less than 5 years the financials they like it. When you talk to the financial team, if it is after less than 5 years, it will just go for it. It is less than 5 years, so just go for it. It was less than 5 years, so we got, yes, of course, the approvals from. And when you have the let's say the customer that they don't have they are irregular customers with no water meter. And when you install water meter, it is all beneficial for the water utility because there will be payments that water, non-revenue water, and all of this will be saved.
Great. There is no other question currently. Just one question from me. Smart
please.
meters. Do you know if they, now it's already been like 10 years, are they still performing, or did they observe any challenges with smart meters in those kind of settings?
I mean, usually, I mean, because it's that's the problem that's happening for all the loggers where we have batteries.
Mm-hmm.
So it is 10 years, so they have to think to change them now.
No mechanical failures because of quality of water, things like that?
No, it's a smart meter, so open, it's full bore.
Okay.
So they have to change the batteries or maybe change the meter, the entire meter itself.
Yeah. So I think the question, the previous one, percentage of recovery, they are talking about recovery of readings, increase of water meter. I'm not giving recovery of readings. What was the average recovery of readings after replacing meters?
And for this smart meters, like we used to have, at the time we had one car with an antenna that will stop at the entrance of the street, and so it will read all the meters that they are in the street, all of them at the same time, and we can gather the data.
And what was the frequency of transmitting those?
I mean, the readings usually, for example, because for this is one we're using is for the billing, but actually because we have to do it at specific time during the month, by the end of the month, we're billing on monthly basis. But actually, that's the reading that we're receiving, like the reading every 4 hours. Every 4 hours for the last 4 hours. So, and the readings, like we can see let's say every 50 minutes, the average of the consumption. So like that, we can be alert. When we do the analysis of the consumption, we can see that the customer, if they are tampering or they are having, let's say, even they started doing having kind of illegal connections. So that's the thing, this consumption analysis, it can be absolutely very heavy for every utility, because we have to understand the behavior of our customers. We have to classify our customers, so like this we understand what kind of customers we have, and of course that we have to take into account, of course, when they are going on vacations, that we have to think that the customer that they are on vacation, that why they are not using water. And also with these methods that we have installed, that they say that they can detect if there is a leak inside the house as well. I mean, actually, they can detect the leak, let's say on the connection, but of course it can hear the leak if it is inside.
Very good. Okay, thank you very much. There are no other questions. Thank you very much, Hassane, for your talk. We have a couple of slides at the end.
Yes, yes,
if
I will,
we could go through those, please.
Yes, of course. Sorry, it's yeah. Oops, this one. I mean, on this one where you can see, this is my email address anyway, that it's here. We have if you want to see it, or maybe if Razia, maybe can you
Yeah,
go
thank
through?
you. So for our participants, we have a YouTube channel. We record all the talks and upload them to the YouTube channel. So Hassane's talk will be there, as well as all the previous webinars that we have hosted. Please feel free to check all the talks at our YouTube channel. Next, please. We have another webinar on 27th of November, again at 1 o'clock UK time. Please feel free to join us then. And this is the title for it, Transition from Intermittent Continuous Water Supply, Governance Challenges and Empirical Outcomes, and with some case studies from India. Also, if you are interested to give a talk about your projects, that work that you are doing, please contact myself, my email address, and also Joe, and we can schedule a time slot for your talk as well. I think that's it. Thank you again, Hassane, for your very interesting talk. Thank you all for attending this session, and we look forward to seeing you at our next webinar. Thank you and goodbye.
Thank you. Thank you very much. Thanks. Thanks a lot.
Thank you. Bye.
Thank you.